Okay, they say write two conditional statements that form the biconditional, then decide whether the biconditional is a good definition. Well, if it's a good definition, then both the conditional and its converse are both true. So they say 3 points are collinear if and only if they're coplanar. It's a fact here that, I'm going to underline these, it's a fact that the if and only if separates the hypothesis, 3 points are collinear, and the conclusion, they are coplanar. So I'm going to cut out here. I'm going to say, cut this piece out here and say, if 3 points are coplanar, sorry, if 3 points are collinear, then they are coplanar. 3 points are collinear, then they are coplanar. And the converse of that is to just say, if 3 points are coplanar, then, oops, then what? If 3 points are coplanar, then they are collinear. That is that original biconditional that they gave us split into two conditionals that have the hypothesis and the conclusion reversed. Okay, so let's see about the truth value of these. Okay, if 3 points are collinear, then they're coplanar. Yeah, if you're on the same line, then that line lies on some plane, some unique plane. So if there's a line that lies on the unique plane and there's 3 points on that line, then all of those points are coplanar as well as collinear. We could say true. Okay. Now what about the converse? Okay. If 3 points are coplanar, then they are collinear. Not necessarily. Watch. These 3 points are coplanar. Are they collinear though? No, they are not. You can have 2 points are always collinear, but then the third point may or may not fall on that same line, and these don't. So just because 3 points are coplanar does not mean that they are collinear. So since that is not true, or another way to say that it's not true is to say it's false, then this is not a good definition. This biconditional is not a good definition. And how would we explain it? We would just say, type it out. Not a good definition. The two conditionals that form it are not both true.